so these are the notes for summation notation. So we start here by talking about the sum of the first n terms of a sequence is represented by the summation notation. So this is the Greek letter sigma, I equals 1. So this is the lower limit. So let's kind of talk about this real quick. I is going to be your index of summation, that letter I right there. And that can usually be any letter. The most common letters you're going to see for the index of summation are I, J, and K. This 1 right here is called the lower limit of the summation. That's the starting point. And n is going to be your upper limit, and that's where it ends. And this a subscript 1 is your expression. So summation notation pretty much means that we're going to be plugging in, starting with 1, 2, 3, 4, all the way to the nth. And we're going to plug it in. We're going to, so a sub 1 plus a sub 2 plus a sub 3. And we're going to keep going all the way until we get to the n. And we're going to add them up. So summation just means to add up all these together, and it comes up with one final answer. A couple of things you probably need to know. This lower limit does not need to be 1. It can be any other number, but for this case, it is 1. So let's kind of get to this real quick. All right, so here it says using summation notation. So expand and evaluate the sum. So here's how I'm going to go about doing this. So my lower limit is 1, and my upper limit is 6. So let's start with I. So the index summation is equal to 1. So we're going to start with I is equal to 1. So just put I equals 1. What I'm going to do is I'm going to plug in 1 for this I right here. So we have 1 squared plus 1. Now I equals 2. So now we do 2 squared plus 1. And we just keep going on until we get to 6. Alright, so then we have 3 squared plus 1, 4 squared plus 1, 5 squared plus 1, 6 squared plus 1. So what you notice is I've just plugged it into here. So 1, 2, 3, 4, all the way to 6. And now I'm just going to work it out. 1 squared is 1. So that's 1 plus 1, which is 2. The next one is 2 squared, which is 4, plus 1, which is 5. 3 squared is 9, plus 1, which is 10. 4 squared is 16, plus 1, which is 17. 5 squared is 25, plus 1, which is 26. And then 36 plus 1, which is 37. And now we're going to take all these values right here now. We're going to add them up. So 2 plus 5 plus 10 plus 17 plus 26 plus 37. So I'm just going to put these in a calculator because I don't really want to make small errors here. So hopefully you can see that there. 2 plus 5 plus 10 plus 17 plus 26 plus 37, and we come up with 97. So usually you can just write 97. Some people prefer to see the sigma notation. But 97 is the summation of this one here. All right, let's try the next one. Oh, sorry about that. All right, so this one, notice this one started at 4, 1. This one now starts at 4. So here, you notice the index also changed. It is now a K instead of an I. So letter doesn't matter. We just know the lower limit's 4, upper limit is 7. So we start at 4. We plug them into here. So this is going to be negative 2. K is now the 4th power, minus 5. Negative 2 to the 4th power, so that's negative 2, 4, 8, 16. And 16 minus 5 is 11. Now we go to K is equal to 5. Negative 2 to the 5th minus 5. Well, if this was positive 16 multiplied by one more negative 2, that's going to give me negative 32 minus 5, which is negative 37. And once again, this can all be checked in a calculator. K is equal to 6. negative 2 to the 6th power. So if this was negative 32, so negative 32 times a negative 2 is going to be 64, minus 5, which is 59. And k equals 7. And I know to stop here. And the reason I know to stop here is because the upper limit is 7. So now we have negative 2 to the 7th power minus 5. And I'm going to verify that in the calculator real quick. Make sure I don't make any small errors. So parentheses, negative 2, close parentheses, raised to the 4th power, minus 5. So the first one is, just double checking it, 11, which is good. The next one is negative 37, which is good. The next one is 59, which is also good. And then the last one, we plug in that 7 here. So 64 times negative 2 is negative 28, 128, so it should be negative 133. There you go. So we have negative 128 minus 5, which is negative 133. And now we're going to add these up. So the way I would add these up, this is 11 plus negative 37 plus 59 plus negative 133. And I'm just putting this in parentheses so you can see. So this is pretty much going to simplify to 11 minus 37 plus 59 minus 133. So here is my answer when I do all that. 11 minus 37 plus 59 minus 133. So 11 minus 37 plus 59 minus 133. And that comes out to negative 100. Let me just verify that again real quick. 11 minus 37 plus 59 minus 133 is 100 according to this calculator. Okay, let's keep going. And now for this last one here, this is an interesting case here. So you'll notice the lower limit is 1, the upper limit is 5, but here we don't have actually a variable. There is no letter here, right? There's not an I. So when we start with I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4, and I is equal to 5, well, there is no number. I equals 1, the answer is 3. I equals 2, the answer is 3. I equals 3, the answer is 3. I equals 4, 3, and 3. So we take all these 3's and we just add them up. So 3, 6, 9, 12, 15 is going to be my answer.